Okay, for calibration, we have been using this barium 133 here, check source, which has a 10.5 year half-life, and it was bought in 2015, so it was started off as 1 microcurie, so it's approximately, it's almost exactly a half-life that it's gone through. So that was chucked under the head of the 123, which is cadmium telluride detector. And over here, after accumulating for the past nearly 800 seconds, over here we have the spectrum of barium 133, and we're going to reset that and focus on the screen and record what happens when we turn on the Desmatron. Okay, so before we do that, if you can set up, guys, if I can ask one of you to lift that up and then set it to a similar sort of distance as we had before in front of the device. Can I ask you to go and put that with in the source box? Yeah. Thank you. Okay, it's
a bit loose on the center.
Yeah.
This is already tightened.
Yeah. Okay, I'll hold this part.
You kind of gooseneck it up like that, so
yeah. There we go.
Kind of moves on its own.
Oh, it's got to tighten up.
Yeah.
Okay.
So
move it over sideways.
Bring it in, lift it up. Just be a bit brutal with it. It gets there in the end.
I was just trying to
there we go.
Get it directly in the plane.
Okay, so that is how we're looking at this. Distance, okay. So I'll put this, I'm going to have to put this on the tripod so it gets a good look at the screen. So I want to keep this all in one recording.
Was the barium in the big box?
Yeah, it was in the big box, in the source box, under the lead, in the actual box in the box. Okay, so I'm going to move that so we get a sensible look at it. Okay, so yeah, off the Japanese Atomic Energy Authority here, you can see the barium peaks are at 81, 302, and the big one, 62% of the intensity, is 356. And so that is essentially the signature that we have now on the screen down here. So we're going to have a look at that in a second. I'll zoom in. Okay, so relatively you can work out from this what is being emitted from the Desmatron. Okay, so
It's going to get a little bit crazy.
It's going to be a little bit crazy. Okay, all right, I'm going to manually focus this so that stays where it should. There we go. Look at that. I can even see the pixels on the screen. Right, lovely. Okay. Right. We've got how much? 51% on the battery and 2 hours, 21 minutes. Not sure we're going to need that long to see a signal here. So what we're going to do is we are going to reset this now. So it goes to 0. Okay, so reset there, and then I'm gonna count down from 5, and I'll start the accumulation a second before. So on my 2, I will start the accumulation.
Okay. I'll start it then.
5, 4, 3, 2, go. So what we see here is it's accumulating in this band here, very, very discrete beam, and
very low power.
Very low power at the moment. But it's one thing. Now, in the 800-second accumulation of the barium-133, it got up to about 30 counts. We are currently at accumulation of 34 seconds, and we are in 7,000 count range. Oh! Okay, so at the moment it's basically fixed at this kind of emission at the moment. Nothing else is happening. It's a very, very tight peak, but it's very smooth. It's really smooth. There's no side peaks or noise. It's just very, very smooth. Okay. So I'm going to zoom into the area around from here to here. There's no energy up here. No energy up here at all. I'm going to zoom into that so we get a bigger...
building like it was last time.
Well, he's got it on very low energy.
It was last time too.
Yeah?
Yep. It's 20 volts input.
Interesting. Oh, no. There's the little knee is coming up here. So we just saw something very strange happen last time, where this peak built, and then after a period of time it suddenly started building another peak. But it's not there yet. Yeah, it's very, very regular. Yeah, it's behaving differently. I don't know whether we had it closer. Did we have it closer?
Yeah, it might have been less than 2 inches closer.
We could try that.
Yeah. I don't know. Let's leave it for this cycle.
Okay.
It's flattening off on the top actually now. Whatever, you can say that's not a characteristic X-ray thing. Unless, I don't know, it's just it's one big smooth peak.
Yeah. A lot of bandwidth.
Yeah. So we got 30,000 counts, not 30. Yeah. Not worrying at all. Okay, it seems to be pretty fixed at that now.
Okay.
So I think what we'll do is we'll turn it off now, and I will stop accumulation again when I go 5. Okay, I'll stop it now. It's fine. Okay, Griffin, we are going to have another hack at trying to measure the signal coming out of the Desmatron here, right? So we got it quite close. What would you say there? It's about 1 inch away from the head of the bulb.
Oh, it's about 1.5 inches.
Okay.
Fairly
Right.
close, but we'll still operate it at low power
Yep.
in the meantime.
I'm going to focus in now on the data acquisition software here. Right, so we are going to kill that, and we are going to clear the data, and we're going to count down from 5. 5, 4, 3, 2, 1, go. Ah, this is nice because we can actually see it in context with the barium 133 when it was a hot sample. So you can see the samples growing here. And I will zoom in. I'll leave it as it is. No, I'll zoom in so that we see most of the barium lines. There we go. So the top peaks here in barium, this main peak here, if it's as it should be, is 356. Or it's whatever. If we go to cobalt, there's 2 lines down there, and cadmium is here. Anyway, we'll go there. It's very, very smooth, isn't it? It's interesting, the first time we ran this, and we can show you, after a while it started to produce a second peak. I don't know whether we're going to see that this time.
Hey?
Here is your barium 133 with your high peak here from when it was active and you did a long sample, and this is the output from this tube, which is very smooth.
Low power.
Yeah. All good information.
It's definitely information. Is it valid? Who knows? Now, was it this kind of level of power that you were doing the X-rays earlier, or?
Yes.
Yes, okay. You weren't cranking it up any higher. So that barium sample was captured for 1,682, I think, seconds. We are currently at 90 seconds.
Volts on the primary.
Yep, 20 volts. Of course, that begs a different question. Once it's at full power,
Yeah.
how does it look?
Okay.
I wouldn't dare place it that close to the tube at full power, but maybe at the end,
Well,
at the table here.
what we can do is we can stop accumulation because we have a clear signal there. It's just getting bigger.
Okay.
I can save the data. I can save the screen grab of the screen,
Yeah.
and then we can crank the power up a little higher and start sampling.
We could do that. Yeah.
Yeah, see if it makes a difference. I mean,
Good.
yeah,
I'd like to see it build that second peak.
yeah. It's not.
That
It
was
doesn't
fast,
seem
yeah.
to be doing it. Yeah, that was interesting, and I don't know whether
glad we were able to record it.
Yeah, well, did we? I'm not sure we did.
Well,
No.
was
we
there a
got
screenshot?
We got a screenshot,
Okay.
yeah. And we've got the data, so we can load it back in and compare it against known samples. But yeah, this is just more of the same, really.
Right.
Very smooth.
And that's why whether or not the sharpness increases with power, that's...
It is something that Matsumoto observed distinctly
Okay.
as he went up the potential on his experiments. Got a really different signal, so... okay, I will get rid of the rest of this, yeah. Is there some separation there? I don't know whether there is. There might be. There's a little chops here, but nothing significant. See, this is cadmium 109, and it's meant to have an energy peak at 0.088 here. And I've got it selected to do that at the moment. I don't want to do that. That there is meant to be 0.088, which means this is very low energy. If that's the case, if I load in the... I have some barium 133. So this big peak here, barium 133, I think that was the 356. And that's right at the upper end of this line. Yep, this is right at the other end of the line. So almost all of your spectrum, in theory, if this is to be believed, is below 356 keV.
Okay.
Guess this would be 303. This would be 276. And it's not seeing it here, but if it was seeing it, this would be the 0.081, which 0.081, I don't know, maybe this is around about, well, if that's 303 and that's 0.081, it's around about 130, 140, is it? Something like that. keV.
Okay.
Which is more than enough to create an X-ray.
Definitely. That would be the upper end of the hard X-ray
Yeah,
spectrum.
yeah. But then why is it travelling a mile away? Oh, not a mile away, but you know,
But
a long distance.
Yeah.
Yeah. Okay, so should we pause that? Let it cool a bit?
Sure, just for a couple
And
minutes.
then I'll stop the sampling here.
Okay.
We'll save that data. And we'll then do it with a higher potential.
Okay.
Yeah?
I'm going to shut it off now.
Yeah.
Okay.
You want to save the dead tubes, or?
No.
Okay. I'm gonna check them out.
We'll throw them on the ground. That will work.
Like firecrackers. Okay.
So that was about 1 inch, wasn't it?
1.5 inches.
Oh, we're not moving it.
Oh, no?
No. We're just trying it at high power to see if there's...
Oh, but that's pretty close for high power.
Yeah, there might be
I
some
think we
corona
Oh, okay. All
that
right.
generates.
I'll defer.
I come back here. So.
Place it, back it up just slightly so I could angle this directly towards the tube. Okay. I think that should be sufficient. All right. I mean, the tube is ready to go. It still has enough life, so
Oh, okay.
whenever you're ready.
Yeah.
So this guy,
This guy.
Great.
yeah, he used to work for my glass blowers and printers.
Uh-huh.
And he copied, like, he never used to make anything for tubes or anything like that. And then he copied, he doesn't sell them as therapy devices, but he makes tubes. He's copied some of my designs.
Uh-huh.
But very cool. It puts different gases in them to give cool
Okay.
effects. And also building the coils into old radios, I do that too. But it's pretty cool. You can spin it back.
What type of receiver is this? Could you go back to the...
It'll turn in a second.
Okay.
It's just the body though, right? It's not in the electronics.
Right. I'm going to put the other one in the background.
Okay.
I mean, the main thing is he's not selling them as a therapy device, more as a light show kind of thing. But yeah.
Oh, it's a floor model radio.
Yeah.
Mercury.
There's Mercury rectifiers in there.
866As.
Yeah.
Yeah, those look like 807 tubes.
807s, yeah.
Okay, ready when you are.
Wait till you see
All
what
right.
he's got on the bottom.
Oh, hold on. I need to take an image of the distance.
Oh, okay.
Here, let's get the
all right,
orange
give me a
peels
sec.
out of the way.
Yeah, look what he's got on the bottom.
Okay, so
Oh.
what do we
He's
got
even
here?
copied my Egyptian. Luckily, it's not the one I've trademarked. I trademarked some Egyptian hieroglyphs.
Okay, so that's our distance there. What do we estimate it to be?
Let's see, we have the ruler here. One, 2, 3, 3.5 feet.
3.5 feet, okay. And we'll go over here. Okay, and I'm gonna just grab a bit of this to cover up the camera because it's getting too hot. It's in that Californian sun. Now I feel like a real photographer with a blanket over the camera. Okay, okay. And just check it's not sampling. Stopped, okay. 5, 4, 3, 2, 1. Okay, well we're seeing lower energy, stronger peak now. Look, it's a harder line there, even though we're further away. And now we're seeing a peak forming here at the second
one.
area. Yeah, it's a this is the previous shape, lower energy and closer, but now we're getting that second peak higher. That is a very different shape.
Yes.
And all of you done, okay, we moved it further away, but you've upped the power. Yeah.
All the way.
It still seems to be, in fact, it's dying sooner.
Mm-hmm. Yeah. Steeper roll off.
But nothing looking like a characteristic X-ray though.
Yeah.
How long do you think you can run it at this power?
Oh, I could do even 10 minutes at present.
That's peak power, is it?
Yeah.
Okay. I suggest what we do is kill the idea of doing one more exposure on this. Sorry.
Okay.
I'd rather go back to the diathermy unit because otherwise we have nothing to compare to nothing.
Okay. Sounds good.
That's what I fear might happen. But this is seeing the second peak that we never saw when we kept it running at a low power.
Yeah.
You got the power turned up a little, don't you?
It's on full, yeah, at the moment.
Yeah, it's talking.
Yeah.
Oh, sorry, it's got my shadow in the frame.
I don't mind, actually. It's a bit bright. It's mostly looking at the screen, so.
Yeah, yeah.
Okay, so is that, we haven't moved it. It hasn't produced. So what's weird?
Yeah.
Because all of that low NG peak wasn't there until you put the lead in front.
Yeah. Yeah. It's falling. Secondary emission.
You think so?
Yeah.
Very, very low energy?
Yeah.
Okay.
Yeah.
That's Alan's going for the spallation theory. Okay.
Yeah. Cosmic rays do it.
Yeah, right. But now it's basically producing the same peak. So the peak in the background there you see is without anything in front, nothing changed.
What's the high voltage in that thing now? About 10 kV?
No, it's about 100 to 200 kilovolts.
Okay, so that sets the maximum particle energy that could come out of it.
Well, and we would expect to see some kind of peak at around 100, between 100 to 200 keV.
Right.
Yeah, there's no peak.
So it's not gamma ray spallation because there's not enough energy in the gamma rays to get through the lead. So something else is coming through there that's kicking off low energy stuff out of the lead. You want to use a piece of iron instead?
We can pause it and put. I will take a screen grab of this,
Yeah.
save it, and then let's get a piece of iron in front.
Grab some plates.
Okay, cool.
Should I, I'm going to give the tube just a bit of a rest.
Okay.
1 to 2 minute rest.
What's going on with this turning off? I don't know.
Yeah, it's getting pretty intense.
Yeah.
More than was done the device.
I need umbrellas. It's just, there's an umbrella. Why didn't I spot it sooner? Griffin,
Yeah,
could you put this umbrella up?
sure. Do we have a stand somewhere?
Well, that would be asking too much. I will.
Where's the... There we are.
Okay, let's get a picture.
Small umbrella.
Movie star Bob.
It's exactly the same peak. when the lead was removed,
Yeah.
which is freaky.
Yep.
This peak went all the way to 0.
Right.
That
Yeah.
says, I don't know what it says.
Attenuating.
Yeah, but like, how's it
There's
getting?
something still coming out of the lead. Maybe it's just.
No, but like, how's it getting through the beryllium window? There's no cutoff.
Yeah.
Well, the low energy stuff. Oh, that's a good question.
Yeah.
There's no, in all the other things, it comes into the signal. This is a hard line.
Right.
Huh?
It's a hard line. Look,
Yeah.
it's basically 0 is 100%, and it comes down from there. Is it? Is
It's
Noise?
the 0th bin.
right?
It's a
Okay.
reference for the MTA.
Okay.
So it's an artifact of the software.
Oh, hold on. No, there is a cutoff. No. Sorry, there's a gap between here and 0.
Okay.
Yeah.
Uh,
Yeah, it goes up.
but this is basically the beryllium window cutoff, and you don't know how high it is at the low energy. It could be
Oh, yeah.
somewhere up in the stratosphere.
So you have to
off.
get the edge of it interposed, you know,
Okay.
Yeah.
because the hole in the middle, it'll go right through.
Yeah.
Mhm.
I get it right here.
Yeah.
Okay. Capture plot.
And if the plot
Capture
changes,
preview.
that tells us it's coming from the metal.
Right.
And this is.
There's 3 of them here.
Jeez.
Mhm.
Mommy, Dad, and
Oh,
little
big
baby.
family.
daddy. Yeah.
No, there's 4. There's one right there.
That's
Oh.
big daddy.
What's that?
Oh, nothing. Don't look up.
Oh, spider above my head. Ah, right. I see what you're saying.
They're enjoying the sunshine.
Yep.
So this was lead, no lead.
Mhm.
Oh, no lead, no lead, no lead. Okay.
Sounds like a good name for a punk band.
Yeah.
Lead.
So I'll get rid of that one. Clear that one. Okay. I'm ready when you are.
Okay, iron.
Mm-hmm.
All right.
He
Gonna hold
needs
the umbrella.
Yeah. Alan, could you hold the umbrella, please?
Where?
There. It's keeping the equipment, the camera from overheating.
I've got another base
That's
somewhere.
Another base would be
Movie
brilliant.
star.
Well, I can't go to the base wall.
Hold on. I'll count down from 5.
We'll be quick.
Do you want to? Oh,
I'll take one.
5,
Team. You
4.
want to go without?
3.
Or with?
oh wait.
No, with
Start with.
definitely.
Yeah,
Start
play it
5,
Yeah.
4, 3, 2. Same story. Hard line on the bottom back end. I'll load in the previous data. Just on the beryllium window cutoff, which is 30 keV from memory. It's even tighter. Oh, but the lead. Oh well, we're waiting. It's the same signature. It's the same signature. Something is able to get through.
But without the metal there, it doesn't-
No, well, we'll wait for until it gets up to about the lead.
Yeah.
It's much lighter than what Griffin had to handle. So I just want to see Paul's got the man in him left.
the name of science.
Hard left line on the cutoff. Pretty much the same as we saw before.
Spike. Yeah.
One other test I suggested. Do this with the detector moved well away out of the line of fire
Okay.
and see if it's RFI induced.
Yeah.
Okay.
And you almost got it on your head there.
Ah.
Run away, run away.
This is a quality sample of iron.
British iron.
British iron, no less. Yeah. We call that steel in UK.
No, it's cast iron.
Is it really?
Yeah.
That's cast iron. We have the chief umbrella holder.
Good day.
Good day. The only one that's cool-headed.
Cast iron is a superior material for disk drives.
Oh, right.
You better brush the spider out of your hair now, Bob.
Really?
Okay, I'll go right into it. Go off your right elbow. And the back of your pants. How's our feet?
It looks pretty much the same.
Okay, out of the way.
Alright.
So you can see how, actually it's slightly broader than the lead.
Okay.
Before it concluded, it's slightly broader. Look, there's the lead peak.
Bob got a tree on him. Oh, they went down.
You see how broader much broader it is.
Broader, yeah, interesting.
And I guess this is just going to fill in where it left off.
Okay.
Looks a little lower.
It does look a little low, yeah. Is that the power on full blast still?
It is.
Maybe there's some wear in the system.
Possibly in the tube itself. I mean,
Yeah. Yeah, curious.
I thought you were going to say curry.
Hmm?
I thought you were going to say curry.
someone's hungry.
Oh, Madam Curry.
I think here's what we need to do. I think we need to have that pointing here and the lead shield there to see if it's coming off the RF, to see if it's noise in the electronics or something, I don't know.
What if we pulled the tube up?
Well, it's not going to be loaded the same.
Yeah, just take the detector and move
Wait.
it over here or something.
Or just possibly perpendicular.
Well, it seems where we move this, it massively changes where the peak on that is. If we move forward or out, it's not the same energy. It's a different peak. It's weird.
It is weird.
That's weird, guys.
Weird and wonderful.
Okay.
I mean, if possible, we could move it even further than the 42 inches that we had it, just to see if there is.
Let's do that. Yeah,
Further
let's
shift.
do that. Yeah.
Yeah.
Okay.
Out of the beam line too.
Okay. I'm
Or
going
in
to
this case, in the beam line, just to see if the idea of it shifting upwards.
Pay attention.
Have I got another spider? Oh, that one. Is that the only one I haven't collected?
No, there's one on your pants leg still,
Oh, good.
somewhere.
Pitching a free ride.
Off your right elbow.
All right.
Wants to stay
Okay,
below.
Oh, look how much different that is. It's shifted, the whole thing shifted left. And we didn't move it.
Yeah.
Yeah, that's interesting.
I mean, that's really shifted. Look, there
Over here, I'll see
to
if I
there.
can find the extra base for it.
Weird.
Right. Yeah, if so, then.
Okay, I'm going to stop that.
Okay, let me stop the tube.
And we are going to save this. This is iron and no iron.
Let's see if we were to.
I could spell iron, right? Weird.
Okay.
Problem solved.
Wonderful. Can we get the it over the top of the laptop as well?
Yeah, I think it's.
And be careful with the tripod.
How's that?
Not really, but anyway.
Just move the chair.
Yeah. I can't move the chair at the moment because the camera. Oh, well done. There we go.
Be careful when you stand up.
I've got the friends, have I? Okay, so I'll clear this.
Okay.
And you're going to move it further out, are you?
Do we want to do double the distance than when it was?
Yeah,
at the
okay.
table? Okay.
Yeah,
So
okay.
right here where the ruler is going to be the.
Right.
Double
Ooh,
distance.
okay. Can we reach there? That's the only question.
That's a good question.
We might have to move the laptop and
Right.
stuff. All of Alan's
Yeah, I get
extremely
it.
good work will be lost.
Okay.
Okay. Okay. Watch out for the
Yeah,
power supply
it's-
for the
they're tangled.
laptop. We can actually undo the laptop power supply. You've got that. That's a limitation.
Well, we can get quite a ways.
Oh no. Oh no. Looks good. Can we?
Go a little more.
Yep. That's good right there.
Right. Just got to get it in line. Get the balance better. The anti-trip things in place. I'm going to kill this.
Yeah, this is on the trip. So there's trip line there.
Yep.
Okay, just be cautious.
Okay. Going to go back to 5.
Okay.
Right.
All ready to go.
Okay, I'm ready when you are.
All right.
So,
I'm gonna.
5, 4, 3. Hold on. Stop. Wait, no, I need. That's okay to roll there. I just want to get a record of what it looks like over here.
Okay.
I might as well do it with that. It's rolling. Yeah, it's good.
Your car door's open, Paul.
Yeah, I was airing it out because we were going to the store. But
We are.
my battery will be dead now.
Okay, I'll do it this because I've got that set up on the. Yeah, he says. Yeah, that's on the. Okay. We have a significant distance here. What do we estimate that it to be?
This is roughly 84 inches, so pretty much double the distance from when the device was situated at the end of the table. That being about 42 inches.
Okay, let's do it. Wait. And so, 5, 4, 3, 2, 1. Well, we're back down to being right at that tight left-hand side now.
I would say it's at an appreciable distance that any RFI would be highly attenuated. Starting to have that broader slope.
See, you could imagine that it's this slope, it's just
Right.
shifted that way, and you can't see it because of the beryllium window. What do you think, Paul? And your nice cool and comfy corner over here.
Yeah.
How do we explain that?
The only way to model if it is nodes, it'd be nice to have it on a track and actually slide
Yeah.
it, see if it goes up and down,
Yeah.
up and down, up and down, up and down. The other thing I was thinking we could do is get a fluorescent tube and hold it, start at the beginning and see if we can see any.
I have tried that before.
Yeah,
It only illuminates because of the
coil.
intensity of the coil.
Right.
And then the other thing would be if the two nodes are present, is the separation between either peaks consistent or does it vary?
Right. Yeah, because usually in the tube they'll move, and you can find a spot where they'll move one left or move right, and hold them steady.
What we can say is when it settles on a peak, it stays growing on that peak.
Yeah. Well, except for that one that started on the low peak and then grew at the second peak.
Yeah, but I think that was some warming up or some power change or whatever. Yeah, it was odd. That first one. Sorry, we're in your chair.
Huh?
We're in your chair.
I'm running to the hardware store. You need anything? No.
Good, thanks.
Okay.
Fluorescent bulb? Fluorescent bulb? The hardware store? Just to see?
You said it'll still, I mean, but then also we wouldn't be able to see it in bright daylight.
Loads of bulbs in there.
You probably got lots.
In the ceiling.
Oh.
Pop one out. But we're not going to see anything in this light.
Yeah.
Well, it's the same signal, just a different...
Just shifted. Yeah.
But this is interesting because this is more like the shape that you get when you have it completely blocked in front by metal.
Yeah, that was the same.
And David said this to me recently.
Okay.
He said, and this was almost the last communication, he said, if I put it in the radio code in a completely enclosed lead box,
Okay.
and the actual radio code is in a Faraday cage, then if he closes the back, he doesn't see a signal, but if he opens the back side, he sees a signal.
Of what, the box with the radio code or with the tube?
With the radio code.
With the radio, okay.
So is that what we're seeing here? All of this stuff over here is attenuated, but for some reason you're getting something coming back. It's at low energy.
Right.
Like
And
reverse.
Based on our reference, what is the actual in KeV that peak would be roughly?
What I can do here is, if I get rid of that one, I can load in, say, the barium 133. So it has this big peak here, which in theory is 356 kV. And we load in what ours is, and it's all the way down there.
Okay.
Like I say, this is the beryllium window cutoff, so we can work out what that is.
Okay.
That is 356, so it's nowhere near there.
Right.
This one here is probably, this is 303, this is 276, and the little peak down there is probably the 0.081. So it's around 100 kV.
Okay.
To 130 kV, which interestingly
It would
is
correspond,
observed in Lena.
but then also it would be corresponding to roughly the driving potential too
Right.
of the
Okay.
coil.
Okay. But those are real X-ray energies.
Yeah, they are.
I mean, they're
Yeah.
real X-ray energies for making X-rays.
Yeah, exactly.
Okay, in the background there, I have the previous 84-inch data, which is peaking or coming from 0 and going up to, I don't know, over 100 kV. So we are going to start this now in 5, 4, 3, 2, 1. It stopped it.
Really?
Yeah. Almost nothing.
The water stops it, yet the dense lead does almost little.
No.
My.
That's what I was saying.
That is
I was able to. That's what I was doing earlier today. If I stepped in front, you basically shut down the signal.
Right.
And I was saying, I think it's the water in your body.
Okay.
I suspect it's actually the oxygen dissolved in the water. Now, if we had a lot of time, we would deoxygenate the water, saturate it with nitrogen, and see if it would still stop it.
With the same effect. Okay.
Yeah.
Okay.
That has to be done, that experiment.
Okay.
So yeah, there is a peak building, but it's it's going to be very slow. Very slow. So I think what we do is we let it run for 600 seconds.
Okay.
And then we let it run for 600 seconds to remove the water bottle. Is it going to last?
Sounds good.
Is it going to last that long? That's 10 minutes apiece. Okay, let's make it 200 seconds apiece.
Yeah, and
all right.
This is pretty clear right now.
Yeah, it's really clear. There's basically very little getting through. It is in the same energy area as previously.
Interesting.
Now, what would be different than the free O2 and the oxygen in the water molecule? What would be the difference? Why would you say it would be the dissolved oxygen rather than the oxygen?
Because
part of
Sundaresh and Bokros did not see any ion synthesis unless they had oxygen.
Right.
And Leonid Oritsky believes it's the magnetic monopoles, which are the charge clusters, being bound to oxygen in the air that cause the different spectrum in Pripyat, above Chernobyl.
Right.
But I before I heard that, I suspected that oxygen was critical.
Right. Yeah.
And you're going to have 21% oxygen roughly dissolved in the water there.
Right.
And if it's cold, it's much better.
Atmosphere as well. Yeah.
Well, no, that's why.
Yeah.
That's exactly why.
Yeah.
It's a partial pressure. So you might find you can increase the suppression.
Yeah.
I mean, it's still getting through, but like I say, you might find if you
highly attenuated,
you dissolve more oxygen in it. Yeah.
Okay.
You might find it even stronger.
If we had sparkling water, we'd have.
Okay, we're coming up to 200 seconds. You've got.
Okay.
No, you need to pull the water out of the way.
No, okay. I mean, unless we want to give the.
And then 9, 8, 7, 6, 5, 4, 3, 2, 1. Pull it. Oh, instantaneously!
That is a sharp.
Literally instantaneously.
Right. Wow. Get the lead connect.
Well, water's your best shield.
Yeah. Well, it's only 3 inches of water.
Yeah.
Wow.
How about that?
That's impressive.
Instantly, this went up to a massive scale. Look.
What is it even at right now?
Well, it almost immediately went into the thousands, having been at 0 at this level. But now you're starting to get the signal down here. If I go back to here, that's what it was. No, this was the previous sample.
Okay.
So the previous sample looks like that, and there's a secondary peak here. The secondary peak is not so obvious until you look at the new data, but now it's not appearing.
Okay.
So there is a secondary peak here, and that is the peak that gets bigger when you pull it closer.
Okay.
So I think what we need to do is, I think we're showing what it's doing now. We need to repeat it and halve the distance, and see if it's, because we're going to see the same story, but I think we're going to get a little bit more resolution.
Okay, so we'll place it back to its original distance.
Yeah. Okay, great. This is really interesting.
Let me put this here.
I mean, this is interesting from a point of view. We know how to shield it around it.
Yeah. Water.
Yeah, water and jacket.
Now that might mean it's RFI. How's the RFI going through water? I don't know. All right, I'm gonna stop that accumulation. So you can stop that.
Okay.
And then we'll move it in closer. That was amazing to see, wasn't it?
Instant.
I thought it was going to grow slowly.
Yeah.
Oh, it was.
0 to hero, like a bullet going off. And what I will do is I will
table.
save the first data.
Halfway?
Oh no, to the end of the table.
Oh, where
Here.
we were
That's where it
before.
was.
Yeah.
Just a little bit closer. There we go. Yeah. Okay.
Well, what about carbonated water? You could get a bottle of that easily enough.
Yeah.
But doesn't it change to carbonic acid? And
Yeah, it's going to be different. It's not quite what we're after, is it?
Okay.
I mean, Alan does have some oxygen for an oxyacetylene torch, and it's not enough oxygen to run his oxyacetylene torch. So he said I could use it to because I got the carbon rods to do the Sundaresan and Bockris test later in the week.
Yeah.
So I want to do that with the fully dissolved oxygen in there, and then no nitrogen or argon or whatever. I don't know, nitrogen.
Yeah.
Okay, this is all set.
Okay. All right. Okay. Let's see if this is still good here. It's still good here. Okay. Well, not necessarily what we thought we were going to discover today, but definitely something.
Well, the good thing is it's a steady. With the new unit, there's several tests that we've done.
Yeah. Honestly, we need to be here for a week.
Yeah.
Minimum.
Yeah.
And it's going to be hotter later in the year.
Right. Well, we can always go up to my place.
Yeah, that's always cold there.
Yeah. Problem solved.
Yeah. Okay.
Okay.
Right. Give me a second. I need
All right.
to. I've saved that. I need to do a preview, but it's such a weird thing. You can almost not see that.
Yeah, the nice thing is Alaska Airlines flies right out of LAX to my town.
Oh, okay. That's convenient. What's the name of the town?
Kelowna.
Kelowna? Okay.
Yeah. In the Okanagan Valley, BC.
Okay, let's do this then.
Okay.
It gets hot like here.
I would think so, especially with that.
Okay.
Okay, ready?
We've got the water right in front, have we?
Yep, right in front.
Okay. 5, 4, 3, 2, 1. Okay, we're getting the peak now, so whether it's coming round the side or whatever, I don't know.
Okay.
I'm going to load in a previous piece of data and scale it to that.
And this is at 42 inches.
Okay, well, it's very much smaller.
Oh, you mean the water?
This is a previous data with the spike, you know.
Okay.
Water. That's what you need. Yeah.
Neutron.
Something, or neutral things that interact. And I was just saying, like, could we deoxygenate the water and see whether it reduces it, or could we super oxygenate water?
I have a gallon of distilled water. Can you try that?
They're still going to have water from the oxygen from the atmosphere.
Maybe. Sealed.
Still,
It's not DI water.
no. Distill's good, but you still need to boil off the oxygen.
It's a boiling water.
Yeah, and boiling water would work.
What about a gallon of gasoline? Scary.
It's still got protein. Yeah, like since we don't actually know what is coming out of there, probably not a good plan.
Yeah, the bike might run faster after this.
Right. Okay. So come here. Have a look at this.
Supercharge your gasoline.
Still the same sharp.
Well, this is the sharp thing.
Quieter, too.
No, this is not the data. This is the old data. This is our data at the moment.
Okay.
Right. So we've got 100 seconds. So it's 95 seconds to go, and then we'll pull it out of the way and we'll see what happens.
Okay.
I think we're going to get this filling in because you'll see if I like down here, it's there. There's a few samples coming in.
Right.
Yeah. This is higher now than this. That was a long sample.
Just the distance.
Yeah, but no, this is when it was closer. That is, I don't know. I don't think I actually. It's this one, 5. I need to look back.
How many seconds?
We've got 30 seconds to go.
Okay.
In fact, what I'll do is I'll zoom into this bottom area here where the... Oh, I don't want to do that, no. I'm going to take it out. 9, 8, 7, 6, 5, 4, 3, 2, 1, now. Oh, there you go.
There it is. I'm just going to hopefully resume back to peak.
Well, it's going to build out that kind of normal shape,
Yeah.
which is shifted that way because it's one of the other distances in between. But all of that was shielded
Right.
with the water.
Percentage, yeah. Well, hopefully when we're able to overlay the energies in KEV, it'll just
Yeah.
provide some context.
Well, I will upload the full data sets,
Okay.
and then you can estimate by having these in the background and knowing where the peaks are.
Okay.
You can estimate where it is because you've got multiple peaks here on the barium 133.
It'd be interesting to check the temperature of the water, then have a control and.
You're going to have to fry it for a long time. Yeah, that's very different. Look where that peak is. But none of that was there until we took the water out of the way.
And it was just an instantaneous change.
One way to make sure it's not dissolved oxygen is to use the high density polyethylene from the neutron moderation.
Right.
Let's see if Alan will let us take. I think there's a cap on it.
Okay.
Oh, Alan.
That was a quick spike.
Yeah. Moderation. Slow down the fast neutrons with the filter.
Yeah. Well, let's see how many seconds are what?
How many seconds?
It's probably done now. Yeah, it's done 470, so we can stop that.
Okay.
How it works with water now.
Right.
So, I'll capture all that.
Mm-hmm.
Yeah. Very cool.
Yeah, we captured all that. That's a really good thing. So I think the last thing we need to do before we go and you do the swap over is HDPE.
Yeah.
Because that
Okay.
has no oxygen in it.
Yeah.
And then it's more a neutral structure rather than the charged structure binding to oxygen.
Yeah.
Okay.
Yes, we found some HDPE, so we're going to try that in place of the water. Right, there we go. Should you choose to accept it?
Yes.
It's nearly heavier than the lead.
Let's see. We just have to balance
Nearly,
this correctly.
not, but probably yes.
All right. That's all. That's pretty secure. Pretty stable.
Okay.
Ready?
Do you not want it slightly higher because it's just in
could.
case things are diffracting over the top?
We just have to find something.
Yeah, that box there is better.
Let's use a crate.
The crate's better. Yeah. Okay. Okay. So this is.
I've been instructed that the dog's taking me for a walk. So
Okay.
I'll be back.
All right. No worries.
Okay. That's the closest you could get without it over
Falling over
Yeah.
and crushing the device. Yes.
Right.
That looks good.
Yeah.
That looks good. I think this is when I know I'm in the right place to do this work. Do you have a piece of HDPE? Yes, I have a house. Right, 9. So this was. How far away was the last one?
With the water bottle right here.
Water and no water, yeah.
42 inches,
42 inches, okay.
and it's still there.
Okay. Okay, clearing it now.
Okay.
And dun. I'm going to load in our usual background reference. And I'll load in the barium 133 so we can get an idea. Okay. Okay. 5, 4, 3, 2, 1. Well, my friends, it's not as good as water.
But we still nonetheless have the same effect.
A little bit wetter than the water.
Yeah, it's a little bit wider than the water. There's very little down here. Yeah, is it? Hold on. This is the previous one with a. This is the normal signal.
Okay.
So, yeah, it's missing all of this stuff up here. So we do 200 seconds on that. We're at 32 at the moment. I'm going to get myself some oranges. Would you like a glass? Would you like a glass of orange?
Yeah.
I wouldn't mind. Yeah.
Yeah.
Thank you. Well, the HDPE does the same thing. I mean, if it's
I can use my same glass. Those 2 seconds on here? How many seconds are we at, Bill?
Well, we need to swap out at 200. It's here. There, 132. So I'll get ready to save. Yeah, there's really nothing in that gap, is there?
no.
Here, look, almost, you have to zoom right in. It's fully attenuated, like a lot.
Yeah.
Wow.
But of course, that begs the question that
Is it neutrons?
if these are within the range of hard X-rays in terms of KEV, the suppressed portion right now of the
Well,
display
if I go here and
would be in excess of 100 KEV, let's say.
this one here, this peak one here is
Yeah.
356,
Okay.
and our data is down here.
Is that hard X-ray?
This is 356.
It's 100 kilo electron volts is around the beginning of the hard X-ray range.
Yeah. Oh well, this is 81, but this over here is in the around the hundreds.
Okay.
Because this here over here is that's the 356.
Okay.
So 356. This is the 384. Okay, so yeah. It's around about 100 or something like that.
Okay. Well then, yeah, by definition, it would be considered hard X-ray. What is being suppressed currently by a material that is ultimately transparent to hard X-rays, which that's peculiar, to say the least.
Now we need a polytetrafluoroethylene because that's meant to be really good at stopping erzions.
I
According
use
to
that
you.
for coil.
What?
I use PTFE for coil designs too. I have some at home. Some chunks.
We need some
we
here.
could possibly use. Yeah.
We need to do this with PTFE.
Okay.
Alan's gone to walk the dog. This is where we would find PTFE.
I'm sure he has it.
A frying pan's not going to do it, is it?
No.
Right. I suspect it's now 200 because we've been talking and not. We're 300 seconds.
Okay.
3, 2, 1, go. Take it out. Okay. It's filled in a lot of the space there. It's filling in this zone here.
Yeah.
So I suspect the water is as good, if not better. The water was thicker though, wasn't it?
3 inches.
We could
This
go
is only.
lengthwise.
Yeah. Well, we almost attenuated it completely to zero.
This
Other
is,
than those very. I mean, why is the low energy stuff still getting through?
Still going through, right? Yeah. That's what I was thinking. If it's lengthwise, we're still getting the low.
counterintuitive. if
Yes,
low energy
completely.
Yeah.
Well, the low energy is able to go, get high energy, ultimately block.
Right.
Should be transparent. So it's just the complete opposite.
Could be the other way around.
The opposite too.
Yeah.
Surreal. We'll try again with the lead.
Yeah. For that, we can place the lid on its side.
We can just put it on
Right.
lead on its side. That
Yeah.
should work. Yeah. All right.
Be
So.
ready for that. However many seconds we have left.
Yeah, it's fine. We've got the story here. Let's do it for another 9 seconds. 8, 7, 6, 5, 4, 3, 2, 1. Okay. File, save as. Okay, this is curious. It's very curious. HDPE. No. HDPE. Save. Clear. Okay. Ready when you are.
All right.
Did you want to
try
give it
with
a
the
little
lead?
rest or not?
Let's give
Yeah,
it,
put the lead in front of first.
yeah, let's give it about a 2-minute rest.
Yeah.
Yeah. It's holding up pretty good.
Yeah, it is. Yeah, which makes me worry. I'm used to these things falling apart quickly.
Well, that's why this is using the older electrode material, so
Yeah, okay.
it seems to be a better alloy.
What's the number? Do you know?
6061.
Oh, okay.
There we go.
Perfect.
It's nice of you.
There's not many places where you could just turn up and there's a lovely curved lead shield for you to use.
Or a 2 1/4 inch thick piece of polyethylene, for that matter.
I was thinking though those bolts go right through it, so
Yeah, but it's not where the center
no.
line is, where he is.
Yeah.
Sweet. Okay. Ready when you are.
Okay. Let me just see, because it's just based on the temperature of the tube. No, it's good to go.
What's going on here? Lovely. It's just lovely. It's just beautiful. Okay. Okay, so let me get this on my other camera. Okay, so now we're going to try with the lead shielding again, having it there and removing it and comparing it to the water and the HDPE. Okay, 5, 4, 3, 2. Same story. It's basically the same story.
Yep.
The radio scan, can we get it behind there? Just behind the lead there?
That's a
Yeah, that's
good idea.
Just in case it's seeing the very high energies.
Right here.
Where is it? It's been cooking in the sun, has it?
You do. I wonder if it corresponds to what's on the computer.
The shade with me.
small little peak in it.
Okay.
It's about roughly the same as we were seeing. What's the energy in 511?
400. No. Well, it's saying the annihilation peak is there,
Yeah.
which is the closest thing there. When we come to swap it out,
Bring me over to the camera.
yeah, maybe, yeah.
Do we want to get it on the camera now?
Yeah. Yeah, we put it down there, it's fine.
Oh yeah, see that really good.
$178 seconds, get ready.
Yep.
15, 14, 13, 12, 10, 9, 8, 7, 6, 5, 4. Try and hold the thing in situ. 2, 1, go.
Here, Paul, could you hold the lid? Thank you.
Yeah.
Not on the radio code too much,
No. Oh. Uh, 120 seconds to go, 130 seconds to go.
Do you think you shut it off, Paul, when it does come to that point?
It's a lot flatter for some reason.
It is? Okay.
Yeah. Than a previous time, but maybe it just needs more accumulation. Go more. 60 seconds left, roughly. 60 seconds. Yeah. $50 seconds left. Two, one, stop.
Okay.
I thought, what am I meant to be doing here? Oh yeah, that's right. I'm meant to be monitoring the seconds.
Here's the radio code so it doesn't melt.
Yeah. Well, the alarm wasn't going off that time, was it?
No. Okay, I think with that,
We should, should proceed with the rest.
yes.